Welcome to this session. This session is on the graphing calculator, and my name is Renee McCormick with the National Math and Science Initiative. We're going to take you through some basics, and when I say basics, I mean really basics. So feel free to use the fast forward key at your leisure and zip right on through things that you already know how to do and have known how to do probably for quite some time. But for those of you that are novices, just getting started with the graphing calculator, I'm going to be very thorough with this, and the tool that I'm using over here on the right-hand side that you see was actually written for a TI-83 Plus, but you can see that my calculator is a TI-84 Plus. So I will be pointing out some subtle differences. There is absolutely nothing wrong with the TI-83 Plus. The TI-84 Plus is just a newer edition. It has more memory. That means you can put up more stuff on it. It can store more data. It can do probably more things than you ever want to do with it anyway. But there is a difference in the operating systems as of late, which means as of about March 1st in 2010. So I'll point out some of those differences. And so it's kind of nice that the handout itself has all the instructions for the 83, but you'll be seeing how I do it on the 84 for those subtle differences. So this handout was really intended to teach students, very young students in middle school, how to get started with the graphing calculator. So please don't let it insult your intelligence, because no matter what your level of expertise, you may actually pick up a few tips or things that you just knew how to do once but have forgotten. So let's start with step one under this procedure and make sure that you know the anatomy of your calculator, because there are several important keys. And I always remind chemistry teachers in particular that as we are going through the graphing calculator and they're not as familiar with it and they're hunting and hunting and hunting for where these buttons are, that's the exact same angst that students feel when they're hunting and hunting and hunting on the periodic table for cobalt. The chemistry teacher knows what cobalt is on the table because they've been doing this for years. So I always remind them to be kind to their students when the students are taking a little longer to suss out where something is located on the periodic table, because they feel their pain a little bit when they're trying to suss out where these keys are. So let's talk about the enter key. It's right here. Hopefully you can see that on your screen, the enter key. And we also use the second function key because that doubles the functions of most of these buttons. And it is the opposite corner. It's the upper left-hand corner, and it's usually got a color. And that color codes to the actual command or function in some cases, like with sine and cosine and such. But it's going to access anything that's written above the key in the same color as the second button's color. Different models of calculators have different colors on their keyboard. The alpha key lives directly under the second key, and it allows us to access, in my case, the little green letters above the keys. So that lets us store information as variables, which is really nice, and we'll talk about how to do that. So some of those pesky constants that you deal with all the time, like 9.8 meters per second squared, you can put in 9.8, store it as G, and Avogadro's number is A, and you have 26 choices of what you can store, since there's 26 alphabet letters. The side-to-side and up and down keys are located right here, and they are exactly what you might think. They let you move up and down and side to side on the screen, which lets you type over something if you make a mistake, or go up or down and grab a previous calculation in the new operating system. The apps key, if you want to access a program, you go to the program key, but a lot of our applications are stored under the app key, and so it's important to know where both of those keys are, and that if you're searching under one for a program of sorts and you don't find it, then try the other. Depends on where you stored it. You had a choice in that. And then the Y equals, the window, the zoom, the trace. All of these buttons that reside under the graphing screen deal with the graphing screen. So if you want to graph a function, y equals, let's say, mx plus b format, then you would have the y equals key, and when you press it, you'll see that I have a couple of functions in there, which I'm going to happily clear out right now. So you may want to do the same, because you'll get random lines on your graphs that are very unexpected later if you don't remember you have those in there. And then the window, where you can set windows. The math teachers do a lot with that. We're lazy in science, so we use the zoom window more often than the manually setting the window. So there's a whole menu here, and item 9 on this menu is zoom to statistics, which is an auto-fit function that we're rather fond of. And then trace, and you wouldn't get this picture, this is based on what I have in my calculator at the moment, but you can trace anything on the graph, and then of course display the graph. And if I have anything in there that's worthy of graphing like that, then zoom 9 is what you saw me press. I'll do it again, zoom, and I just chose the number 9 on the menu. I know what it is because I do this so often, When you see an arrow on a menu, that means there's more to come. And so I could have zoomed to integer, zoomed to stat, or zoomed to fit. So I like zoom stat a lot. And so there's my graph. So now I can press trace, and I can actually use my arrow keys to hop. You see the little blinky cursor. It's hopping from point to point. And notice it's telling me the x value and the y value, which is the ordered pair for plotting that point. It's also telling me that I have on graph 1 and that my x's are coming out of L1 and my y's are coming out of L2. That's a comma there in the middle. So think ordered pair algebra 1 where you wrote x, comma, y format. That's exactly how the calculator speaks back to you. All right, so you can adjust the brightness of the screen using the second function in your up arrow to get it brighter, or the second function in your down arrow to make it darker. You have several settings there. I'm going to clear my screen at the moment. But one of the things that we need to do is a little bit of housekeeping. So we need to set your mode, especially if you're in a physics class, because there's a nasty little trick that happens when you reset a memory, which teachers often do to keep children from cheating. And when you reset the memory, all of these functions slide back over to the left-hand side of the screen. So your mode button is right here. And so you can see that I have set mine on degree, but it would, if I just cleared my memory, it would, or upgraded the new operating system or whatever. It's a fresh load, basically, on this calculator. It's going to all go to the left-hand side of the screen. So I like for my notation to be normal, not scientific, not engineering. I like for my decimal to float, so I get a whole screen full of calculator vomit. If you use a program to collect data with your calculator, it may truncate that at 3, so you need to go back and check that from time to time. But it is nice for you to be able to work in degrees. So notice it's flashing, and anytime that the calculator is flashing at you, as opposed to flashing at you, it's going, want to, do you want to turn this on? And if you do, then hit enter, and indeed, there you have turned it on, and you can move away from it to double check. As long as it remains dark, it's on. So I want to stay in functions, not parametrics, not polars, not whatever that other thing is. It's been too long, I'm sorry, I'm not a math teacher. Then I want my graphs to be connected, I want sequential, I want real, I want full, and I'm on the 84. So I'm on the new operating system of the 84. There's a separate video for how you get the new operating system on your 84 or your 83. But notice that what I'm about to show you only exists for the 84. But I can go down to a new screen. So they've got the back up here at the top. So arrows mean if you want to go back, then go up. And these arrows mean if you want to keep going, go down. So I'm just pressing my up and down arrows. So I want the math print function, but if I decide I don't, I can switch it to classic. And then this is about changing back and forth between decimals and appropriate fractions, so exact numbers versus decimal numbers. I'm going to let my answers go to auto mode instead of choosing which way I want them. I want the go-to format of the graph. I do not want that, so I'm going to select no there. I do want my diagnostics on. They are typically off. So to get to any of these menus, I'm just using my arrows and navigating my way down there. So if you're seeing yours off, please take a moment and press over to the side and put it on. The reason I want it on is we're going to do some graphing eventually, maybe not in this recording, but in future recordings. And you need to know if your linear graphs are the appropriate model, or would you need a curved model for the equation for the lines that fit your data. And so we look at R values and R squared values, which I'll explain in detail later, but you won't see them at all if you don't turn the diagnostics on. Same with an 83, but a different method for turning that on. I'll show you in just a few seconds. And then you can set your clock if it amuses you, but you don't have to. All right, so to get off of a screen like this, notice that above the mode button is written quit. It's like a second mode to get to quit. So the main thing I want you to do is make sure that you're in degrees. And then the catalog is where it literally catalogs every command this calculator can do. So if you ever forget, you can always just go here, and it's a big, long alphabetical list. What we want to do for the 83 users, or the 84 users that have not yet upgraded their operating system and couldn't do what I just did to turn diagnostics on, this is how you can do it a second way. We'll just go second and 0 to access the catalog. See, it's written above the 0 key. So I press 0, and there's the catalog. Notice the alpha lock comes on, which means I can now use these green keys to hop to various parts of the alphabet in this long alphabetical list of everything that this calculator can do. So I'm going to go ahead and press the x to the minus 1 key because D is written above it. And that pops me down at least to the D's and saved me scrolling painfully through the A's, the B's, and the C's, but I must scroll through the D's. So I keep going, keep going. There's diagnostics on. Notice my little arrow is pointing to it. Make sure your arrow is pointing to it. Press enter once to paste it on your screen. And it has not executed the command because it's giving you a chance to abort this mission. If you want to hit clear, you got there by accident. If you did get something by accident, you can hit delete, you can hit clear. But I really do want diagnostics on. So you're not done until you press enter and the calculator says you're done. So these are the little screens showing you how to do that in this handout. That was me showing you how to do it in real time. So the next thing that we usually struggle with are numbers and scientific notation. I'm just going to clear my screen on my calculator. You have got to use the EE button. It is not acceptable for you to use 10 and a caret. So like multiply by 10 and a caret. And I'm about to prove to you why. To get this EE button, which it's really not a button, I wish they made it a button, but unfortunately it lives as a second function above the comma key. So here's your comma above the number 7. There's the EE color-coded to your second button. EE stands for literally enter exponent, which means the button, pressing that button, is giving you times 10 to the. So when I press second EE, that's taking care of times 10 to the, and all I have to enter then is the exponent. So let's look at two different ways to do this calculation to prove to you that you got to use the EE button if you want a correct answer in science classes. All right, so let's take the number 8 and let's divide it by 2.5 times 10 to the minus 2. So this looks like 8 divided by 2.5 times 10 to the minus 2, or 8 divided by 2.5 times 10 to the minus 2. To enter that properly and get a correct answer, I obviously hit 8 and the divided by, as you see on my screen now. So let's go for the 2.5 second EE. You cannot use this minus sign over here. This minus over here is a function, addition, subtraction, multiplication, division. You have to make this a negative number by using the negation key, which is this little minus. It's all cute down here next to the enter key in parentheses. And the exponent is 2. So I'm entering the minus 2 part. And I press enter, and I got an error. What did I do wrong? Oh, I hit it somehow. I hovered too well above my times key and actually pressed it. So sorry. Would you let me try that again? Can I just start over? 8 divided by 2.5 second EE minus 2. Enter. There we go. 320 is the correct answer. So if you've been freelancing and trying to do this on your own by using 10 caret minus 2, and I'm just going to tell you that sometimes teachers teach you to do that because they don't particularly know the calculator well enough to do the EE button. So be polite and say, we really should be doing it this way, or just be quiet and just do it the right way. So if I took 8 divided by 2.5 times 10 caret minus 2, you might think that's the same, but it's not. And so let me also, now that you're looking at my screen here, point out a new feature of the new system. If you ever get stuck because you went into exponent mode, that little blinky arrow is saying want to get out of this. So you can press that arrow, and that's just my side arrow. It was reminding me it was my side arrow. I just press it, and I'm back down in normal typing. But I can press enter, and that is an incredibly different answer, don't you think? 320 is the correct answer. 0.032 couldn't be more wrong. So you really need to embrace the use of the EE keys. Enough said about that. I'm moving on. You also want the latest operating system in your calculator. It just makes it behave better. So again, I say there's a separate video for upgrading your operating system. Let's determine right now whether you need to look at it or not. That operating system, forgive me while I change this for just a second because I can't remember this. I didn't memorize this. These are the current operating systems as of today, which is September 10th or 11th. I think it's the 10th. It is the 10th on 2010 because it's a Friday. That's today. I just made this document. So when you go second plus on your calculator to get to memory, see mem written above the plus key? A lot of things you can do here. You can clear all your lists. We'll do that quite a bit, which is item 4. But item 1 is simply about. Tell me about the memory on this calculator. So just press enter to access it, or you could press the number 1 to access it. And I'm on for an 84 Plus Silver Edition 2.53, which is the most updated system for TI-84s. But if you're on an 83, 1.19 is the most updated system. And if you don't have something as large as 1.19, then you are going to want to upgrade your operating system. Same for the 84. If you're on an operating system less than 2.53, you want to upgrade. And these are free upgrades. You don't have to pay anything. You just follow my directions in that video about updating your operating system, and you'll be good to go. If you are swanky and are a calculus student and have a TI-89, then you're going to have to figure out how to work your own calculator. Let's just say that up front, because I don't have an 89, and I don't know how to do some of the things I'm going to show you on these 83s and 84s and 89s, but there's lots of good tutorials out on the web. And if you're a smart kid with a TI-89, you're smart enough to put in linear regression tutorial TI-89 into Google or Yahoo and find yourself some directions. So 3.10 if you have a super swanky TI-89 titanium version. All right, so I'm going to go back to my graphing calculator document. This is where we were, and I'm going to make it big and carry on. So enough said about operating systems. You should be able to go second plus and the number 1 or enter and be able to access it and figure out what operating system that you have. We're going to carry on with what we're going to do next. And so I want to use the second plus memory function for a different purpose, which is to clear all of our lists. You can clear them individually, but it's tedious, and I'm lazy. So I'm always going to do something the fast way. And I really appreciate it when students teach me an even faster way. I learned a couple of new tricks just this summer. Just when I think I'm all that, I find out I'm oh so not all that. So I press enter to put the command on my screen, but I'm not done until it says done. And so if it's blinking at you and not saying done, that means you need to press enter. I find that approximately 20% of the population suffers from a disorder called enterphobia, where they don't want to press the enter key because they're frightened. Get over that. Just press the enter key. We can always start again. We can always go clear if you mess up and go second, plus to get back to that menu, press item 4 and press enter again. So conquer your fear of the enter key. There is no way to back up efficiently on this when it comes to commands, but you can go forward. All right, so if we chose to do reset, we would reset our entire calculator, which is bad if you have things in it that you want to keep, like lists of data or programs or applications. But I will tell you, in my classroom, I cleared the calculators as students came in the door on test day and out of the door on test day, because Texas children cheat. And they cheat really well. And so learning to clear the memory of all your different calculators is very useful if you're an educator. All right, so we can also link calculators and transfer programs if you lost something that you needed. Hopefully a friend has it. We can do this with the operating system as well, because item 9, I think it is, it may be 10, which would look like just a 0 on this operating system, or on this calculator menu is OS for operating system. Again, I can't remember if it's 9 or 10. Guess I could solve this mystery. If I go second link and up twice, there's the operating system. Oh, it's way past that. Okay, never mind. After they run out of 1 through 0 digits, they go into A's, B's, C's, and D's. There's all kinds of things on this menu you can explore. But we get there, again, by going second link. So I can send all sorts of stuff. It's really nice to send data. If you've done a lab and one person in the group has collected the data in the lists and put them in the calculator, you can send those lists to other calculators. So you can see that item 4 is to send lists, and then you would select which ones that you wanted. So I would just select them by hitting enter and say I want to send L1 and I want to send L2. Of course, our calculators have to be linked with a calculator link cord, calculator to calculator. But once I've selected them, I like to move away and make sure I really selected them, because this is a toggle switch. Enter on, enter off, enter on, enter off. So I just turned it off by pressing enter again. So I come and press enter, now it's on. Watch the subtle change on that arrow. Press enter and it's off. Press enter and it's on. So I usually, with my old eyes, have to move away and make sure I've got them. And then we would arrow over to transmit, and if I were really connected to another calculator, I would just press enter to execute that command. They, in the meantime, while I was getting ready, should have, I think a second quit. They should have gone second link and been the receiver. So they should hit enter. I'm not going to do it right now because it'll mess up my calculator because I'm not connected to somebody else. But if I pressed enter, it would say waiting. So there's more on that to come. So if we want to enter a number in a list, which we do a lot in science, if they'd asked me, I'd have said, can we make that stat key data? Because that's where I want to put my data. But instead, the math folks at TI said, yeah, your data is really statistics. In a technical sense, they are correct. So I appreciate that. But it would be easier in my life if it said data. But anyhow, it says stat. So you press stat, and you have several things on this menu. Edit is where you go in and enter numbers or change numbers in the lists or make new lists. We can sort the data ascending. We just have to tell it which list. We can sort the data descending and tell it which list. This is useful for educators when you've given a quiz or a test, you want to just rapidly put the grades in. And then I've sorted them before to see physically how many A's did I have, how many B's, how many C's, how many D's on that quiz or test. And then you can clear a given list. So you have to enter an argument, which is the list that you wish to clear. So if you wish to clear a list, you have to tell it L1. So let's talk about that. Look at your keys, 1, 2, 3, 4, 5, and 6. In color above them is written L1 above the 1, logically, L2 above number 2, L3 above number 3, L6 above number 6. You get it. So I would have to tell it L1. So I go second and 1 to tell it L1. And then if I wanted it to clear a second one, I'd go second L2 and tell it to clear L2. And it just did it. If you hit enter, it will do it, but you're not done until you've hit enter and it says done. Now, this will happen to you, happened to me just last night teaching a college class. Occasionally, a student will delete a list on accident. No one does it on purpose, trust me. So your default situation is that you have 6 lists displayed, L1, 2, 3, 4, 5, and 6. If you just arrow over, it can only display 3 at a time, but it will display 1, 2, 3, 4, 5, and 6. In the new operating systems, you can, I thought you could arrow over to get more lists than that, but I cannot. All right, so occasionally a student will do this. They will have been up here trying to do a batch transform command or something, and they will have hit delete instead of clear. Delete is not your friend when you're in your lists, especially if you're at the top, which you will hear me say the tippy top. If you're at the tippy top of your list, where that whole column, it can now be given a command line. L2 could equal whatever you wanted it to equal, like the reciprocal of L1 or the natural log of L1 or anything else. But if the student hits delete, well, guess what happens? The list is actually deleted. So that's a problem. How did we fix this problem? Well, first, let's go back to stat and run setup editor. So item 5 is the setup editor. You're not done until it says done, so conquer your enter phobia and press enter, and now it's done. And now let's check by going back to stat and edit. It's back. And the cool thing is, if it had data in it, the data would come back with it. That's kind of nice. That's like a big whew kind of moment if you've actually done that by accident. Okay, so we're going to actually put some data into these lists. So I got here once again. If clear button doesn't work for you when you want to quit something, then go second and mode to get to quit and clear. So I'm going to clear screen and start with you. So if you've rewound or whatever and your head's spinning and you had to stop and go get like more caffeine or something, join me now. Press stat, hit enter to press edit. All right, so now we can enter loads of stuff, and you can fit 999 data points in each list. Not that you would want to enter that much data, but you can if you are, masochistic enough to do that. So clearing the list we already talked about. Excuse me. I want to clear them all. We talked about that. Let's actually enter some data into the lists. So I'm looking at some data from students in a physical science class that are doing an experiment where they poured a liquid into a graduated cylinder, took the mass of several predetermined volumes, and so we're going to enter in their data. We're just going to steal it. So in L1, I want to enter, because it tells me to enter the volume in L1 and the mass in L2. So when you transfer in your brain these beautiful titles on top of this actual data table that's printed on the page, you got to now think about L1 and L2. So it's kind of helpful to actually just jot that down above or to the side. If this weren't black, I'd write it in here. Oh, it actually shows up on my screen. I don't know if it'll show up in this recording, but I would jot it down in there to remind myself where I put my data. So to enter data, you literally press the number 2 and press enter, and it pops into the list. 5, enter, 8, enter, 15, enter, and 20, enter. Done. Double check your typing. 2, 5, 8, 10, 15. Or 2, sorry about that. 2, 5, 8, 15, and 20. All right, now moving over to the next list. How did I do that? Your arrow keys. Just move over. Just use your arrow keys and navigate to that spot. Not the tippy top spot, but the first spot within L2. So 52.4 and enter. 56.0 and enter. 59.6 and enter. 68. You can put the .0 if you want, but I have learned it's pointless. Because see, it goes, you don't need that. So you can just stop at 74 when you have a .0. If you need anything other than that, notice it displayed them. So notice that the .0s are not being displayed. Also, if we put in big long numbers like 52.43764, we have a bunch of significant digits, it will truncate them in what it can fit in this physical space. But it will hold all of those numbers for calculations. So do not panic if you are putting in big long numbers and you don't get to see all of your number and you see that it's rounding for you. It's doing that for display purposes only. For calculation purposes, it's keeping all that data. All right, so we have our data in, and again, I remind you, we don't want any nasty surprises, so it's a good habit to get into to press your Y equals at this point and clear, using the clear button, any functions that you had in there. You saw me do that earlier. We want to see our data plotted, but let me give you one more teaching moment about this data. What you just did is basically plot ordered pairs, 2, 52.4, 5, 56, 8, 59.6 for plotting points. So you got to kind of get into the calculator's brain and understand what it's doing. So now it can give us an opportunity to actually plot these points. So if I go second and Y equals, look what's written above Y equals, stat plot. You want to plot your statistics, you want to plot your points you just put in, go there to get started. Now yours may all say off. So I'm going to turn all mine off using this plots off command. Conquer the interphobia. Done. I'm going to go back to stat plot. Now they're all off. And then yours may all say L1, L2. It doesn't matter. We go inside and we fix these how we want because we are the architect of our graph at this point. So I go into number 1 by pressing either the number 1 or pressing enter. And it's blinking at me. You want to turn this on? Do you? So hit enter if you want to turn it on. Then a scatter plot is our preferred mode of operation in science class. You're big kids now, big adults now, whichever the case may be, and we don't want to draw pictures anymore. We want to mathematically model data. So do not select line connecting points very often. If you would like a bar graph, which is appropriate in certain instances, especially in the biological sciences, then there's your histogram. These other 3 things are box and whiskers with outliers, and piecewise functions. And so if you don't know what those are, then don't be using them to get into a little more advanced mathematics. Then you have to tell it where you want your x's to come from. So if mine didn't say L1, again, I would press second and the number 1 because that's where L1 lives, right above the number 1. Very logical. And then the Y list is L2. And then if you're over 40, join me in the big fat dot moment. Otherwise, you can use the more petite plus sign. Or you can choose, if you get down there, you can choose the more petite plus sign. And if you're a young whippersnapper, you can probably see those tiny little dots on the screen still. But I'm sticking with the big fat dot. Your choice. You're the architect. All right, so at this point, if I hit graph, I got nothing. No panic. No panic. If I hit zoom, I can choose to zoom in, zoom out, zoom box, zoom decimal, zoom square. I'm a fan of zoom 9. There. All it did was auto-fit my window to my max, my min on the X, my max, my min on the Y, and indeed, it's a fast way to auto-fit the data. Now, apologies to math teachers because sometimes I've gotten in trouble because I've taught Zoom 9 to young students before the algebra teachers had a chance to teach them how to manually set windows, which is an important skill. It's a skill that we need to use when we actually plot stuff on paper, is using the whole graph, making sure that you've scaled your graph properly and all that sort of thing. So there's a whole giant week-long unit on the window button in algebra class. So if you're an educator, please have a conversation with your math department and make sure you're not jumping the gun teaching students Zoom 9, which is going to ruin your math teacher's lesson and make them incredibly unhappy. And there may not be enough chocolate in the vending machine to repair their unhappiness. All right. So if you ever hit the graph button and you don't see what you expect, don't panic. Just embrace the Zoom 9 command. So now it has plotted my points. They're stacking up like a fairly straight line, but sometimes they stack up like a curve. So that brings us to the point of regressions. This particular lesson is about linear regressions. So I'm probably going to stop at the end of this linear regression moment after we get the line in and we actually can solve algebraic equations with the line. And I'll probably do another recording on curved regressions because that's a whole nother lesson. Same technique, very subtle in terms of your new calculator skills, but much more complicated in terms of your mathematical understanding. All right, so let's see what's going on here. If your graph looks like this, it might be linear. You should probably test it by running a linear regression. And the way we test it is we go to the stat button. But we've done all we can do with these functions. We've edited, we have our stuff in, don't want to sort ascending or descending or clear a list or set up the editor. We want to calculate. So item 4 on this menu is a linear regression, but I want to spend a moment on item 1. Item 1 can be very useful. Item 1 gets you one variable stats, and if you tell it which list you want to run this on, look at all the data it will do for you. So I'm going to say, let's run it on L1, second one, and hit enter. And it says, let's look back at what that data really was. It says, look, X bar is your mean, so X bar is telling you the mean. And so if I averaged 2, 5, 8, 15, and 20 the old-fashioned way by adding them up and dividing by 1, 2, 3, 4, 5 data points, I would come out with 10. It does it for me. If I just want to know what the sum of 2, 5, 8, 15, and 20 is, it tells me the sum of X. You've probably seen that big capital Greek sigma as a summation sign before. So that's telling you the sum. And I can also get the sum of X squared, which statisticians care about a lot. I can get standard deviations, and there are 2 different varieties, and for the life of me, I can't remember which one is which at this point. But I also find out that I had 5 data points, which is useful when you have like a whole screen full. You don't want to physically sort down and figure out that you took 20 samples and just count 1, 2, 3, up to 20. You can just run this one variable stat on the column, and very quickly it would tell you how many samples that you had. And that little arrow at the bottom means there's more to come. So it tells you that the minimum X value was 2 and the median was 8. It also tells you about quartile 1 and quartile 3. It also tells you that the max X value was 20. So if you want to average really quickly, that's where I use this function the most. Whammo, right there. If you want to get the sum really quickly, whammo, right there. So one variable stats just needed a few minutes of our attention. We'll carry on, however, with where we were, which was running a linear regression. So I'm going to go back to this regressions part, right there. And I'm going to quit this screen, second quit, get back to my graph. Okay, I'm back on task. Thanks for the diversion. Now I want to actually calculate a linear regression. So I go stat, I arrow over to calc, I select linear regression. Notice there is quad and cubic and quaternary, different lesson. I just want to hang out right here at linear. That's item 4 on the screen. You can go dinky, dinky, dinky down a menu with your arrow keys. Dinky, dinky, dinky. I'm way too lazy for that. I just look at the number 4 and press the number 4. I get it on my screen. Now I want you to humor me on this. There's a method to my madness. What I want to kind of get you into the pattern of doing is saying to this, now go get my X's. My X's right now on this example are living in L1. Then go get my Y's. They're living in L2. Then I want you to run this regression, peachy, give me some statistics on it. But I want you to do one more task, and that is paste that little bugger into Y equals. I want to actually paste it into Y1, or 2, or 3, or 4, but you know, One's as good as any of them. So I want to add this, this, and this onto this screen. I don't just want to run the regression. I want to run the regression and paste the value into Y1 so that I can do lots of other fun things with it. All right, so I go L1 by pressing second 1. I remind you the comma lives above your number 7. L2 by pressing second 2, and the comma still lives above your number 7. Now the beast, getting Y1. I'm going to do it the hard way first, and the hard way is how 83 users will have to do it. The hard way is how 84 users who have not yet upgraded their operating system will have to do it. One of the nice features of the new operating system is the easy way to get y equals, so I'll do that secondly. But I'm going to do the hard way for 83 users first, which is go to vars. Okay, so vars, the vars key. Because I'm looking for a y variable. That's why they buried it under this key. So I go to vars by pressing vars. None of this other stuff looks all that useful, so I'm going to arrow over to y vars. So I'm going to press my arrow key. There, I pressed it. And I get a menu, most of which frightens me. Parametric and polar functions, on and off, I don't even know what that means. But function is where I'm going to go. So I press the number 1 to select function by just pressing enter or the number 1. And there is my Y1 that I seek. And I press enter, and it pastes it on the screen. So to get that, I went vars, yvars, and enter or the number 1, whichever way you like to do it. You might like enter better. It doesn't matter. You can get there either way. But that gets the Y1 pasted, but I still haven't executed this command because it's blinking at me at the end of the command going, want to, want to, want to. So enter your, conquer your phobia, and there you go. And now that's how I got this screen full of information. So let's demystify this screen. All right, so now let's figure out how to get the Y1 pasted in the new operating system. This is what I promised you was the easy way. So I'm just going to use my back arrow, and I'm going to delete out that Y1 and show you once you upgrade to the new operating system on a TI-84, how much easier this is. You're going to go to second, I'm sorry, not second, take that back, alpha, and trace. And when you go to alpha trace, the thing that pops up is a whole list of your y equals, so just hit enter to choose Y1, and there it is. So one more time, because that's really fast, I'm going to go back, I'm going to delete it, and I'm going to go alpha, trace, and there it is, and just choose enter, and voila. All right, so if you execute that command, this is what you get. This screen. Y equals ax plus b is the same as y equals mx plus b, if that's how you were taught. I'm old, so I was taught slope was symbolized by m. I never understood why. But in computer language, they use a for slope, and this is a small little computer, so TI decided to use y equals ax plus b, but it's just a variable. And so in this case, a is my slope. No calculating rise over run, by golly, by golly. I don't have to do that whole change in y over change in x thing, the whole old hard-fashioned way. It just flat out tells me what it is. Also tells me that my y-intercept, which has meaning, is 50. And then it gives me two equations. This is excellent fake data, by the way, because a perfect fit for a mathematical model is 1. If it has a negative 1, that means it's just a negative slope. If it has a positive 1, which is understood here on this screen, then it's a positive slope. But normally these come out, because they're experimental data, in numbers approaching 1. The closer to 1 you are, the better the data. So we were doing a lab last night in this college class I was teaching, and most of my students were getting R values on the order of 0.987, 0.989, somewhere in that range, which means, dadgummit, they did a good job of getting a linear fit. So the R is telling you linear fit. R squared is what we usually look at for curves. So next lesson, when we deal with curves, then we will see a difference in these numbers. All right, so in other words, yeah, linear fit is just peachy for this. So This is just a recap of how an 83 user would get this all posted in. And this is a different method. This is a longer method. It's not the method that I use. But I could have gone to get the Y1 pasted on my screen. I could have gone and done vars and gone to statistics and then chosen the first thing on that menu and then arrowed to the equation where I'd get a regression equation, and then it would finally have put it in there. My way's a little faster than this way, but you choose whichever method you may already know is the method you should use. All right, so I'm coming back to my graph, and it just never ceases to entertain me that it will draw that line for me. And it's not just connecting the points. It is a perfect fit because of that R value of being 1. We know it's a perfect fit. Well, that line went through every single one of those dots. So it hit them all perfectly because it's fabulous fake data. All right, so this is just the second way to do it, and this is what I put in. So this is the way I usually do it. And now we can actually calculate on the graph. We can trace by just selecting the trace button. And what the trace button will allow you to do is pop from data point to data point. See the blinky cursor? See the blinky cursor? So it's just giving me, as I pop along, oh yeah, that was 8 and 59.6. It's giving me the values for my ordered pair for that plotted point. This one was 15 and 68. This one was 20 and 74. It's just reminding you. Now, if I go side to side, it doesn't really matter. Whichever way I go, up or down or side to side, it's still popping just point to point to point. So that's just if you want to go from point to point. But if you want to actually calculate with these, that's a different story. So let's calculate a value. There's only 2 ways we can do this, right? We know X and seek the value for Y, or the other way around, where we know Y and we seek X. So let's do we know X first. So I'm just going to clear that off and not trace anymore. So now I'm actually going to use this to calculate. So here's the math moment. Hit your Y equals. What are you calculating with? I'm calculating with this algebraic equation 1.2x plus 50. 1.2x plus 50 is what Y equals. So I can algebra myself, and I can do exactly what I'm about to do with algebra. Trouble is, people often make algebraic mistakes. You may not be one of those people, but I'm kind of one of those people. So I might divide when I should have multiplied. I might write 1.2 as 2.1. I might do all sorts of stupid stuff. So the calculator's a lot more trustworthy with its algebraic skills than I am. So as long as I want to calculate within what you see graphed, which is called interpolation, as opposed to beyond the graph, which is called extrapolation, then it will calculate using that equation within this range. So I need to pay attention to what I seek, and my X needs to stay within the values that I actually put in here, which were 2 to 20. So if I go beyond 20, or if I go backward the other direction with less than 2, then I got trouble, and I'm going to have to change my screen. So moral to the story is the calculator can only calculate what it's displaying. So if you want it to calculate more than your range you're displaying, change what you're displaying with your window and like zoom out. That's the easiest way. Okay, so let's say, let's see, okay, what do they want? What do they give me here? Solving for a value of Y given X, let's say that you would like to know the total mass when there's 17 milliliters of liquid in the graduated cylinder. So to do that, we're going to press second trace. And when all else fails and you get to this menu and go, oh, I can't remember what to do, just hit enter. And it will remind you, oh, this is what I do when I know what X is. X equals, well, X equals 17 in our example. So then just press enter, and magically it reminds you that Y1 is equal to 1.2x plus 50, and that's the equation that it used to solve when X was 17. It plugged it in. 1.2 times 17 plus 50 is 70.4. So you get your Y value. Pretty daggum slick and faster than you can do it, huh? So if we want to go beyond that, let's see if this handout does. This handout does not go beyond that. So if we want to go beyond that, again, let's look at our data. Stat, edit. Our data went to 20. So let's make up a new problem where what is the mass of 27 milliliters of liquid. I'm going to go beyond my range. I know that because I'm looking at my data. If I auto-fit it, it's auto-fit between 2 and 20. That's that picture we're looking at. But if I'll go zoom and choose out, which is item 3, it appears nothing really happens. But when you hit enter, look at what you get. Oh, it ooched, very scientific word, ooch. It ooched all my data points much closer together. Now I can calculate beyond the range in both directions much easier. All right, so just ignore this gobbledygook at the bottom. So second trace value gets my x equals again on my screen, and I enter 27, and it tells me y then equals 82.4 grams. Or you can use this algebraic expression up here, 1.2x plus 50 is what y is equal to, and you can crunch it out the algebraic way. So that's kind of cool. Now what this handout does not do, that I'm going to do, is give you the end of the story, and then I'll stop this recording. The end of the story is how do you get the value for y when we know x? We got that. Okay, how do we do it the other way around? When we know y and want x. So you know y value and seek x. Well, that's even easier. Quit this screen. All you have to do is go to your y equals and put in the value, and it's going to graph a horizontal line, and then we will find the intersection of it. It's just that simple. I wish they had a thing on the menu for that, but they don't. So we have to be smarter than the machine, because even though you paid well, $100+ for it perhaps, you're still smarter than the machine. So when you know a y value, simply put this value, place y value into y2 or 3 or 4 or 5. Just put it in a blank y, and then go second trace to get to the calculate function and choose intersect, which is item 5 on that menu. I know it's sad, I have it memorized. Choose 5 and hit enter, press enter until the intersection is displayed. To obtain x value. All right, so shall we? Let's say that we want to work backwards. Let's say we want to know how much liquid it would take to get a mass equal to 100 grams. Okay, so I simply will go second trace, but resist, oh wait, first go back to y equals. I should have put in 100, sorry. I put in 100. That's my y value, just 100 grams. Okay, now when I graph, as long as I see the intersection, I can get the intersection calculated. If you ever hit graph button, that's all I did to get my graph back was hit the graph button. If you don't see the intersection, then zoom out again and again and again until it appears. Once you have the intersection, you're golden. So now I just go second trace, choose item 5, which is intersect, and it says first curve, so I hit enter because that is not the word intersection. It says second curve, and I hit enter because that's not the word intersection. It says guess, heck no. I hit enter again. I keep hitting enter until I get the actual intersection. Okay, there are math lessons buried in that guessing business and all that, and you may have more than 2 equations on your screen, which would just be silliness. You should keep it clean, but you can hop around and choose them and all that stuff. But I just like to keep it simple with 2 equations on the screen, and off we go. So when y equals 100, it tells me right here that the x value, x, which is volume in milliliters, is equal to 41.7 milliliters. So let's try that again. Let's say I want to know 150. Okay, I'm going to not confuse myself by leaving the 100 in there because I'll have a line for 100 and a line for 150. I just type over it and say 150. Hit my graph. I don't see an intersection. Zoom out, which is item 3 on the menu, Doesn't look like it did anything, so press enter. More ooching of our data points. Here comes my intersection. Now I'm golden. So I ignore all that junk at the bottom, and I just go second, trace, intersect, enter, 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 until the word intersection shows up. So at 150, mass equals 150 grams, volume equals 83.3 milliliters, which makes sense. Okay, so one last comment before we leave this one. There is value in this y-intercept. If we come back and reread the problem, because it's been a while since you've seen it, you're a good sport for sticking with me. If you reread this problem, and we had an equation of y equals 1.2x plus 50, and we know that x, these are my x's and these are my y's, we know that x is volume and y is mass, then what we're doing is solving for the mass. So what is the significance? I'm going to zoom 9 my graph and get rid of all that ooching. What is the significance of the fact that that point right there is 50? I didn't start at 0. I started at 50. Well, if we read the procedure again, they pour a liquid into a graduated cylinder. So when x equals 0, I have no volume in it. Y, which is mass, equals 50 grams. So that must be the mass of the graduated cylinder. So not only does slope have meaning in equations, but so does the y-intercept, especially in science class. So that got us through linear regressions, plus a lot of other skills. I'll do a second recording on some curved regressions here in a little bit. And I appreciate you listening, and I hope that you knew most of this and got to fast forward a lot. So best of luck. Embrace your graphing calculator. It's actually going to make your life a lot easier.